This project is a self-erasing whiteboard with color recognition so that you can select a specific color and only erase lines of that color. What you're seeing is a picture taken from a Raspberry Pi that we will then take and process the colors so that we can select a specific line to erase and have the whiteboard be able to trace that path through G-code. After capturing the image, the file is stored and the Raspberry Pi takes the file and converts it into an image that we can then later send to a computer to have converted to G-code. You can see here the previous image taken and filtered out for just the green color. The green color shows up in the 7 pattern, and we can then take that and upload it to a computer. This next image shows when we try to filter out the red. Depending on the range that we used for the colors, we can actually pick up several different kinds. So we're actually picking up the red as well as the orange and the pink. So it's very important to have the lighting stay similar so that we don't have any changes or variations, so that we can pick a specific color and keep that range. One thing that we'd like to do eventually is to have a color pattern already on the board so that it knows the general range of colors that we would want to filter out. The program we use to trace out the image is Laser Grbl. This program has lots of settings and things that you can change to be able to vary the speed and the accuracy of your cut or your erase in our case. And it was important for us to understand how this worked. We felt like we came to a good conclusion on what would be best for us. The next thing that we needed to do was to establish some bounds, basically saying here's the edge of the board, here's where the picture starts, so that it can accurately trace the image. This is the setup we decided to go with. It's 2 Arduinos that power the servo and the motors, and one Arduino has all the motors on it, and the other Arduino takes the laser program from Laser Grbl and transfers it to a servo code to lift and lower the eraser so that we're not erasing things that we don't intend to erase. It's important at this point to make sure that the program knows where it's at, where it's going to, and where it should end. So right here you can see we're moving it left and right, up and down, and we'll eventually settle on a place and call that our home position. The next thing we want to do is define where the picture is going to be. As you can see, there's some black lines and corners on our board that defines our writable or erasable space. So we can only write in a certain space that is erasable by the eraser that it can be reached when the carriage is moved either all the way to the left or the right. After finding all corners and reference points, it's easy to be able to run the program appropriately. Take note of the vertical black line. What's going to happen is the program is now running, and because of the way we've got it set up, it actually traces the border first. It thinks that there's a line there, and so as it comes back across, it'll then go up and it'll erase that black line. One of the problems we found that we kept having was that the belt wasn't tension tight enough, and so it often would skip steps, and so it would lose track of where it is. So right now it knows exactly where it's at to erase that black line. That was the border. And as it traverses to the right, however, it does skip steps again. And so you'll notice later on as it begins to go and trace the 7 out, it traces the 7's pattern, but it's offset to the left a little bit. And that's one of the problems that we were having biggest issues with, is the belts weren't quite tight enough. It was hard to hold it and then get it tightened down so that it would stay there. We could have used a better mechanism to do that. Some of the other things that we wanted to do is we wanted to have all the computer programming on the Raspberry Pi itself. We didn't want to have to hook up a computer, but we had some issues with the Raspberry Pi talking to the Arduino directly. So we decided to take the Raspberry Pi, talk to the computer, send the image, and then the computer can easily communicate with the Arduinos and be able to source the code. We were grateful to find Laser Grbl. It made the operation of the motors very simple, and the servo in the middle does a very good job of activating when the laser would normally be active. The rest of this segment is going to be the program finishing. It thinks it's tracing over the 7, but because it skipped the steps, it's not. So it's going to finish what it thinks it's doing, and then it's going to return to home. And because it skipped steps, the home is also off, so we do have to stop it a little early so that it doesn't run off the board. One thing that would make the setup really easy is to have limit switches so that as it travels, it would know exactly where the edge is. There would be a switch to tell it you've hit the edge. And then it would know when to stop, and we wouldn't have to go in and manually update where all the corners are and be able to use image processing that way. So I'll let you watch the rest of this. It'll finish that off and it'll return to home. Thanks for watching. Bye.